Back, everyone. And we're off and recording. So our next presentation is from our colleagues at IBM. So we would like to welcome Anand Singh and James Jushchuck from IBM. And I'll let you guys carry on from here with the topic, research computing use cases. Thank you so much.
Great. Thank you for having us. Let me make this in presentation mode. Okay, great. Yeah, so today we're going to provide an overview of IBM Cloud and as well as some research use cases in IBM Cloud. So I'm James Jushchuck. I'm a cloud developer at IBM Center for Advanced Studies out of RTP, North Carolina. And I'm joined with Anand Singh, who is our cloud architect for the same team. And overall, we do university relations with universities projects, research projects, as well as courses. And we are both the focals for IBM Cloud with CloudBank. So if you're working with CloudBank and you have questions related to IBM Cloud, we can get connected via CloudBank and help you. So here you see an overview of IBM Cloud's features. At its core, though, IBM Cloud is an open and secure cloud provider. I want to highlight one of our major products that we leverage is Red Hat OpenShift, which is a managed Kubernetes environment. With that, you can run workloads on-prem, on hybrid, or on multi-cloud environments. You won't have to deal with vendor lock-in, and so you can build your application once and then run it anywhere. As well as that, we have the standard bare metal and VM services and IBM-specific Power Systems and Z mainframe servers. And IBM Cloud has a wide breadth of services here. Of course, I won't describe them all, but I just wanted to highlight that IBM does have many, many services available for many different use cases. And I'll dive a little bit more into the AI analytics side. But if you're curious for yourself to explore these, you can see them for yourself at our catalog, which the link at the top is cloud.ibm.com/catalog. So here, each of these tiles is a product that you can click through and get more details and documentation and pricing. But more specifically, AI analytics tools we offer, these come from being built off a history of IBM's innovation and research in AI. We have the Watson portfolio, which includes the natural language classifier and natural language understanding tools, as well as Watson Studio, which is our managed Jupyter Notebook environment, if you work on data projects with that. There's also some personality, insight, speech text, many different ways to leverage our AI models. And then if you're building your own machine learning models, we have the machine learning service, which manages the entire life cycle of your model from build, train, deploy, and then retrain once deployed. And then on the analytics side, we have the analytics engine, which provides Hadoop and Spark environments, and IBM Cognos dashboard is a way to visualize your data. So it's just a selection of the tooling that you might be interested in your research projects. Here is some resources to help you explore further. You can register for your free IBM Cloud account at the registration link. But we also provide a developers network with resources on how to get started, some guides to build sample applications, and blog posts to get you exposure to what you can leverage IBM Cloud with. There's also academic access through IBM Academic Initiative, which can provide you software and IBM Cloud offerings for academic uses for free. And finally, we have our own team's website, which includes research use cases that you see how we collaborate with. And so again, reiterating that as you work with CloudBank, if you encounter more questions with IBM Cloud, us two are available to be connected, and we can help you explore IBM Cloud. And so with that high-level overview of IBM Cloud, I'm going to pass on to Anand, who will go over some research use cases on IBM Cloud.
Thanks, James. Hello, everyone. So let me start with some of the research use case I've collected over the past few weeks. So this is one very appropriate to the audience out here, cloud busting for an HPC environment. So this is a use case where we demonstrated the busting capability using IBM Spectrum LSF to the cloud for ADA workload, because they can have some time requirement for sudden surge of uses. In those cases, it makes cost-effective sense to go to the cloud and use the resources for your peak time and then come back to your on-prem environment for the normal time. So that process is called cloud busting. So we offer templates, Terraform templates to automate this kind of solution for you, which you can use it from your on-prem to cloud. Basically, the multiple component around transferring of data with IBM Espera, or managing the data consistency and using different type of caches, and then using file object storage and the compute platform in the backend could be automated. And we ran a simulation and scale up to 20 kV CPU in this particular researcher's use case. Next. So another one very popular these days is AI pipeline. So every cloud platform comes up with a way to access, to build and deploy your AI pipeline, which we call managed services. But then there are some open source services for managing AI pipeline like Kubeflow. So this particular open source project is also helping to simplify the AI pipeline creation as well as the infrastructure needed to run it. The way this particular open source project does, it uses the RACE, the distributed computing platform with event-driven system, which allows user a Python-based API. So you can use Jupyter Notebook or Python API to build your model. And that way you are free from hassle of libraries as well as the infrastructure on which it can run. So for example, you can start with this open source infrastructure on your local laptop, building out your local machine. And when you are ready, you can switch to any backend infrastructure to work with. So it's connected, this particular framework encompasses different type of cloud providers. IBM is part of this open source initiative with the project CodeFlare. And in the backend, we have provided two types of already integration option, one OpenShift and one code engine for a serverless platform. So depending upon your use case in AI pipeline, you can go into the serverless platform, which would give you a cost-efficient way to run, or you can go to the OpenShift platform, which where you can have the stateful containers. So I wanted to highlight this is an open source project, but leveraging in the backend IBM Cloud integration. You can go into the website and either collaborate, do the collaboration, or leverage all the resources and cookbooks out there. And that also highlights our commitment to the open source. And given this container-based environment, now we have traditional strength from the Red Hat to do these kind of projects. So one such example of a RACE-based open source project to create this particular data pipeline, which is a health and life science use case, where researchers wanted to take spectrometer images and do the annotation and anomaly detection. Now these images are really, really big, from 1 GB to terabyte scale. So now even annotating these images become really difficult task, because you have to break these images into thousands of parts and annotate each part through your algorithm. And once done, you give it to anomaly detection engine to kind of find the anomaly. So all this requires a lot of resources. So again, this was developed with the same approach as we saw on the RACE platform and with open pipeline with Python. And the backend infrastructure was selected as IBM Cloud OpenShift and the code engine to do the data annotation and anomaly detection part of the pipeline. Now, this is another example where people used, some of the researchers within IBM Cloud used cloud infrastructure and compared it with our Summit infrastructure or AMD at ORNL lab. So the task was to see, is cloud efficient in this kind of work? And they wanted to forecast 2 days weather in an hour. And they just wanted to mix and match different type of VM images to see with different memory, CPU, and optimization to see which one gives more performance. And they could do the forecast in different number of CPUs, like with AMD 980 cores, cloud with 1300 cores, and Summit using only the CPU part of it with 1900 cores. Some key insight what researchers could find, that it's not about how big infrastructure you are using. It's all about fine-tuning the infrastructure. So you have to be the HPC expert as well as the infrastructure expert to kind of merge the two worlds. For example, they figured out smaller VSIs gives better balance in the computation as opposed to the large VSI. So 16 CPU, 64 gig images, multiple of those as compared to 48 CPU and 92 gig virtual server instances. They found the previous one performed better. So that was the key takeaway, that you need deep HPC expertise along with the deep cloud expertise to get the optimal value for your money and time invested in these research. Next slide. This is another example, again, an AI pipeline, but not on the open source platform, but totally using IBM Cloud platform. The idea was to predict soil moisture with the satellite measurements, and the researcher want to see the capability of different type of infrastructure and then runtime to finish their AI pipeline. And they compare with pure virtual machine, Docker images with certain libraries, and then Docker images, means container images, not from the Docker, but from Singularity, and saw some performance enhancement with different approaches. So overall, these cloud offer, so in summary, I can say cloud offers multiple way to decrease your cost and get more value out of your time invested into your project. And if anything has variable need in terms of processing, cloud becomes a good tool. And adding that with an open source engine where things I'm doing on my laptop and I can scale it into a cloud would be a dream. And that's where IBM's focus is, and that's an ask for everyone. So if you're doing this kind of project, it's better to go on some of the cloud infrastructure. So how I'm doing on time. So James, can you switch to the next slide?
Sure.
Yeah, I think we're at the wrapping up stage here.
Okay, so there are other use cases. We can provide the links for them, like COVID-19 literature through the Watson services, drug candidate exploration, or the one which our team is collaborating on, Guiding AI for the Blind, which is using the AI/ML pipeline on IBM Cloud Platform, along with the other genomics and accelerated molecular discovery. But you can find more about them on the IBM Cloud research use case links. So thank you all for listening. This was very high-level overview, but our goal was just to say the suitability of cloud for the researchers in the information science and the computer science domain. So now we're open to any questions.
Okay, fantastic. Thank you both so much. We really appreciate hearing about the IBM Cloud. I think that you've joined into the Cloud Bank program, and so we still have a lot to learn, but it's really great to hear that your services kind of are built on optimizing the nuts and bolts of the process for the researcher, because we tend to like solutions that abstract away the details that we really don't care about. So it's great to hear that. Can you maybe comment quickly, as we're almost out of time here, but help us understand the way that IBM is kind of unique in its integration with other cloud providers in the sense of hybrid? And so the sense that I have is that your AI services run just great, but that can cross over onto other platforms and make use of their compute resources. Can you comment on that really briefly?
Yeah, sure. And that's an excellent point. Right now, with the OpenShift platform, which gives us a platform which can run on any cloud, because anyone familiar with the OpenShift and Kubernetes world, they are like a cloud operating system in itself. So now our services are tightly integrated with the and running on top of this OpenShift platform. So it can be just deployed on any infrastructure you like. So you can have the OpenShift interface to access them, as well as the cloud provider interface to access those services. And that's becoming one of the key differentiator for IBM. This multi-cloud play with a cloud operating system, it's a standard cloud operating system.
Yeah, okay, excellent, fantastic. Well, I'm going to call cut it there just because we're trying to stay on our tight schedule here. So I will say once again, thank you both so much for presenting. Really, really appreciate it. Lots of cool stuff to learn about on the IBM Cloud. So with that, we're going to switch to our next speaker, who is